So let's look at some data from the U.S. Department of Agriculture. It lists some total caloric sweeteners used by Americans in pounds per capita for the 50s, 60s, 70s, 80s, 90s, and the year 2000. So our independent variable, the years, goes from the 1950 through 2000, and our dependent variable, the y values or the range, actually ranges from 110 to 152. So if we were asked to graph this by hand on paper, we would need to have the 50s decade, the 1960s, the 1970s, 80s, and the 1990s. On the left-hand side, we would have to denote our range value or the y values. We could start by showing a zigzag showing that this is not starting at 0. Likewise, same thing here. But we're starting out with the 110 mark, 120, 130 pounds, 140, and 150, and then 160. And in the 1950s, the average American consumed about 110 pounds of sugar. The 1960s was 114. The 1970s was 124. The 1980s was 126. And the 1990s was 146. As you can see, this data somewhat fits a straight line. We call it a linear relationship if the data can be represented by a line. And we can determine what that line of best fit is to make predictions about where we expect sugar consumption or sweetener consumption to go over the next few years. So let's launch a graphing calculator and see if we can predict our line of best fit. So this online graphing calculator allows us to first of all change to projector mode so we can see our values, our x and y axis labels better. And then also we're going to change our x-axis to go from 1940 to 2000 with a step of 10. And our y-axis is going to go from our 100 pounds of sugar through 160 pounds of sugar, again with a step of 10. And again, these are sweeteners, not sugar. So now that we've done that, we're going to go over here to the left and we're going to add a table. And that table is going to include the 1950s, the 1960s, 70s, 1980s, 1990s, and we didn't have data for the whole decade of the 2000s, so we'll leave that out. And our 1950 data was 109.6. 1960 for that decade was an average of 114.4. 1970s average was 123.7 pounds of sweeteners. 1980s is 126.5. The 1990s was 145.9. And it nicely plotted those points for us. So the next step is to figure out what our line of best fit is going to be. So we click on Add Items, and we want to have an expression, and we know that this is going to be a line of the form y equals mx plus b, where m is the slope and b is the y-intercept. So let's go back to our data. Between these two decades, we changed our change in y, the pounds, over the change in x, can be represented by 114.4 minus 109.6 over 10 years. So 114.4 minus 109.6 divided by 10 means that we have increased our sugar consumption by 0.48 pounds per year. We'll take 123.7 minus 114.4, divide that by 10, and we get 0.93. The slope between these 2 points is 126.5 minus 123.7 divided by 10. And lastly, 145.9 minus 126.5 divided by 10 is 1.94. So our slope between these guys ranged between 2800ths and 1 in 9400ths. So almost 2 pounds, 1 decade, just 2800ths, about a fourth of a pound throughout a different decade. So our line of best fit is going to have a slope somewhere in between this range. You can try to take the average of these 4 slopes, or you can pick a number that you think is going to best represent it off of top of your head, and then what we'll do is we'll play with the numbers to see where our line ends up being that looks like it fits the data the best. So if this is a line, we're going to start with the equation y equals mx plus b. So y equals some slope that we know is between 0.28 and 2, or 1.92. So let's start with 0.8 maybe, times x plus some number b. Now that number b would signify when is it crossing the y-axis. In other words, at what time do people not add sugar to their diets? So we're going to plug a number in and just see what happens. Obviously it's going to be a fairly small number. 0 is not working because with 0 there, we're not seeing anything in our graph. So let's start with maybe negative 500 years and see if we get anything. And I'm just going to zoom out here and see if anything's even showing up as far as our line is concerned. And it's way, 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 way up there. So negative 500 didn't help. So let's try negative 600 and see if it's getting closer. And at least now it's coming closer to our points. We'll try a negative 1000, and we're getting closer. Negative 1500, too far, but now we're able to at least zoom in and start to see our numbers and how they look on our graph. So then let's try negative 1400. So it's somewhere between 1400 and 1500. 1400 is above the line, 1500 is below. So let's try negative 1450. And we're starting to look like we're fitting our line fairly well. So let's zoom back into where we were from the 1940s to the 2000s. And what we're trying to do is create a graph or a line that represents the data. It's not going to go through all of the points because that would be a jagged line, but we want it to be as close to our points as possible, going through as many as possible, being a little bit below some and a little bit over others. So it looks like we're a little bit too low for most of this. So if we try a negative 1460, that's not helping us. 1455 is a little bit better, but it looks like my slope might be too steep, not steep enough. Let's play with this slope now. So 0.6 0.75. X doesn't help us. 0.85 is still not there. Way too high. 0.8 looked like it was a pretty good fit. I just don't like the fact that we're not quite up there. So let's try 0.79. That was worse. 0.81 doesn't work, so it looks like 0.8 is our better bet here unless we change these values as well. So let's change this to 1450. Okay, that's not helping. Let's try 1460. 1470. It's looking better. Let's try 0.76 and then bring our numbers up. 1350, 60, 70, you get the idea. 80 is too much, perhaps 75. So now we're getting some numbers below, some numbers above, and then you just tweak. 0.75 maybe. We've got to bring this up. And this isn't a precise science, but at least you're kind of getting the idea of how this is going to work. Now, let's see if this actually kind of makes sense. So what this is saying is that if we zoom out somewhere around the 1800s, when we weren't adding additional sugar, if the data in this website is to be believed, that makes sense because in the 1820s, there was very little added sugar to the American diet. So I hope you'll go back and play. Graph the cane and beet sugar, or figure out the line of best fit for high fructose corn syrup. Dig out the data for salt intake for the U.S. diet, and have fun with it.